AB Calculus 2.6 Limits at Infinity. Alright guys, today's objective is to investigate limits of infinity to find horizontal asymptotes. So this is like a very intuitive definition, right? If the function is defined over the interval some value a to, I don't know, infinity, then as the limit goes to infinity of the function, it reaches L. Basically what that means is that the function can be made to go arbitrarily close to value L by taking x sufficiently large. That is it. That's moving to the right. And all you gotta do is make that negative value, and this will become negative infinity to a, right? And then you're looking for the asymptote on the left hand side. As I just implied, there could be more than one horizontal asymptotes, right? This particular expression right here, guys, right, could be read three different ways, but they're pretty much the same thing, right? You should take time to copy that down. And essentially, and you could change the order in which you say it as well, right? According to the book, this means could be read as limit of x as x approaches infinity is L. Or you could say limit of f of x is L as x approaches infinity. This portion could be at the beginning, where it is now, or at the end. It makes no real difference. Now, the difference between these three items is that one says approaches infinity, the other one says it becomes infinite, the other says increases without bound. They all mean the same thing. Okay. So you might want to draw this out on your note. Let's say we have y is equal to L over here. And sometimes this thing goes up this way. Sometimes it comes down this way, just like this one. Or sometimes it comes down and dips across this way. It gets closer and closer and closer like this. Sometimes it oscillates, and yet it decreases as you go along, right? Some of you might have seen that already, right? So in any of those cases, it really doesn't matter how you get there, as long as x goes to positive infinity, it's approaching the value L. If it falls in any of those scenarios, then we say that is true. Now, you could copy everything over again just to say it goes to left, negative infinity. But I think you get the idea, right? All right, guys. So let's move on to do some problems over here. And if you feel brave, pause the video and try this on your own and say what you get with this. All right, guys. I see that you're back. So let's try it, guys. For something like this, you know, we learned the rule in the past, but this is where we're going to do it, okay? We're going to go with this theorem that I didn't actually write it down, but here it is, guys. This theorem basically says the limit as x goes to infinity of 1 over x is equal to 0, and the extension of that is n. It just means the same thing, right? So if it's raised to the power of n, so if you think about this, this is nothing more than 1 over x times 1 over x dot 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 1 over x repeatedly, the n copies of it. So if that is going to 0, and if you have n copies of them multiplied together, of course that's going to 0 as well. Okay? All right, so we're operating on this assumption, right? 1 divided by a large number, or 1 divided by large number to the some power will go to 0. So we have to use that fact. Well, if that's the case, then we need to make it look like that. Oh, by the way, we are doing infinity over infinity cases, right? So if you plug in a value, number that goes on forever, a big number, you end up with infinity over infinity. So how do we deal with that? We simply multiply by, I generally like to do it this way, multiplied by the reciprocal of the highest, with the leading term of the denominator. In this case, it's 1 over x squared, like that. If you do that, that expression becomes x goes to infinity, 2 minus 1 over x plus 1 over x squared over 4 minus 3 over x minus 1 over x squared. And I'm going to do this time. Some professors would like to see this, but in this class, I don't think it's really necessary, but I'm going to just do it once. Minus 2. So using the limit law, you could distribute, quote unquote distribute, right? This, top and bottom, and then you could distribute it across the plus and minus signs, right? And then you do the limit as x goes to infinity of 1 over x. Getting kind of lazy now, so I'm just going to copy that. Copy, paste. And that is, oopsie, plus there you go. That's 1 over x squared. That is, oops, we don't need, actually we do. It's a 4 minus, and you could factor out the 3 in the front, right? 1 over x minus 1 over x squared. Now, we know that the limits of x goes to whatever value of a constant is constant. So that is equal to 2 over 4. That's minus 0 plus a 0 minus 3 times a 0 plus a 0. So far so good, guys. All right, that's good. So what's that equal to? Answer is, that's right, 1/2. So what's happening is that as x goes to infinity, my y value goes to 2. So that's essentially what this is saying. S as x goes to infinity, y is approaching 1/2. So horizontal asymptote, in this case, is that y is equal to 1/2. That's the limit. Okie dokie? All right, guys. All right. So we have this thing going on. Oh, by the way, we're not doing this. You don't have to write that out, but you should be thinking it every time. Okie doke. How about this one, guys? Let me choose green. I feel like green right now. Once again, I'm going to multiply by the reciprocal of the leading term of the denominator. It's 1 over x to the 4th. 1 over x to the 4th gives you the limit as x goes to infinity. Oopsie, infinity. And that will yield 1 minus 1 over x squared plus 9 over x to the 4th. And we have 2 over x minus 1 over x cubed plus 1 over x to the 4th. Now, when you have this over here, we know that this is, you should be thinking this, right? The same thing as 2 times limit x goes to infinity of 1 over x, but that goes to 0. And according to the rule here, guys, that's a 0, that's a 0, that's a 0, and that's 9 times the limit of 1 over x to the 4th. So that's a 0, right? But I want you to write that out. Because 0 minus 0 plus 0 divided by 1 minus 0 plus 9 times 0. And that gives you 0 over 1, which is 0. So what that means is that as x goes to positive infinity, y goes to 0. So this particular graph is approaching, as it moves to the right, positive x-axis. Okay? All right. How about example B? Let's go with navy blue. All right, guys, we're going to be multiplying this with, once again, leading term of the denominator. That's what I prefer to do, right? That's 1 over x squared, and that will yield limit as x goes to infinity X minus 2 over x plus 1 over x squared. That's going to be 3 plus 1 over x plus 2 over x squared. And limit as x goes to infinity. That's x minus twice the 0 plus a 0, 3 plus a 0 times twice the 0. And that's going to give you guys, if you look at it, the limit as x goes to infinity of a 1/3 of an x. And as you know, that's just a line. Y equals 1/3 of x just looks like this. So x goes to infinity, it's approaching either this way or this way, right? Well, what that means is that this tells you how fast it's increasing, but it'll be increasing forever. So answer is infinity. So in this case, as x goes to positive infinity, y also goes to positive infinity. So this is a fancy way of saying this is a slant asymptote. And as you learn from pre-calculus, if the difference of the term is 1 and numerator is bigger by 1, it's a slant asymptote. If this is a fourth, it would have been quadratic asymptote. If the difference was 3, let's say this is, I don't know, 5, this would have been a cubic asymptote, and so on and so forth, right? Anyways, and then, oh look, if the denominator is bigger than the numerator, it always becomes a 0. If these two are the same degree that is the ratio of these two. So there are little shortcuts, but I don't want you to use them. I need you to see the work. Showing the work is definitely important. Otherwise, yeah, please show your work. This is slightly different. Now, if you look at the numerator, going by what I just mentioned, that is power of 1. But the square root of the x squared is also power of 1. But if you ignore this for a second, isn't that essentially square root of x squared? Oh, guys, I don't know if you remember this. Let's go magenta on this one. The square root of x squared is absolute value of x, and that is defined to be x if x is greater than or equal to 0, and negative x if x is less than 0. This right here, super important. Now, please note that this is going to positive infinity. I don't like this. I'm going to change the question. I want this to be slightly more interesting, so x is going to negative infinity. Oopsie. There you go. Negative infinity. Okay. So now what do I do? Well, why don't I multiply this by 1 over x? And I think this is about the same, isn't it? Well, there's a problem. If x is a negative number, and when you square it, it becomes positive. You square root the positive, it's positive. So denominator is a positive number. But it's 1 over x over here, which is a negative number. So this is a negative number. So this turns out to be negative 1. We can't multiply by negative 1. Excuse me. So what we gotta do is make it positive 1. See that? That helped us figure this out. So I'm gonna put a negative sign in the front. So when you negate a negative number because it's going towards negative infinity, this thing becomes a positive 1. That is a positive 1. And we're good to go. I'm sorry, not positive 1. Positive and a positive, right? So they're equal value. We could continue on now. When you do that as limit as x goes to negative infinity, that gives you 1, doesn't it? Right? And when I multiply that out, that's square root of 4 over x squared plus 1. Now, you could distribute the limit to the top and bottom, and then the limit goes inside the radical. So it's the limit of that plus limit of that, right? So after multiple limit laws, that's 1 over square root of 4 over 0. Sorry, my bad, my bad, my bad. So, sorry about that. So you should be viewing this thing, this part, as 4 times the limit as x goes to negative infinity over 1 over x squared. When you have that, this is 0 times 4, right? So you're thinking as 4 times 0 plus 1. So that is 1. Yes, we're done. We could say that as x goes to negative infinity, y is approaching 1. So that was it, guys. So this page is completely packed. So we have an observation, guys. If the numerator has a degree m, polynomial degree. I should have added the word polynomial. Right? Polynomial degree, and then polynomial degree of denominator be n. If the numerator is bigger, essentially the limit as x goes to either positive or negative infinity, f of x becomes either positive or negative infinity, right? If the difference is 1, it's, what did I call it? That's right, slant asymptote. If n minus 2, sorry, n is 2, this is a quadratic asymptote, etc., etc., etc. All right, guys. If the numerator is smaller, if the denominator is bigger, we learned what? If you could go back and look at the example that we did, and you could sort of generalize that, in that case, as the limit as x goes to the positive or negative infinity of the f of x, that will go to 0. And if they're the same, the limit of that is whether it goes positive or negative of the function, then this right here, star, will be the ratio of leading coefficients. Right? So over here, the first one, it'll be some sort of asymptote, either slant or quadratic, but most of the time, we're going to be dealing with this part, guys. Most of the time. And here, the horizontal asymptote is y is equal to 0. And here, the horizontal asymptote will be y is equal to the ratio of the leading coefficients. Look good, guys? All right. So we have this question. As usual, what you should do is sort of like try to pause the video and see if you could do this on your own first. Okay? It's more fun that way. All right. So I'm going to assume that you're done already. If you're not done, do me a favor. Try it on your own. So, this implies find what? Horizontal asymptote or asymptotes. And we're saying that there could be more than one horizontal asymptote. So what we're going to do is we're going to try to find both of them. Here we go. So what is the limit as x goes to positive infinity? Well, as before, I see this, and when I see that, I'm thinking, all right, I need magenta on that one, guys. It is so important. We're going to go magenta. So that is x if x is greater than or equal to 0, positive. If x is negative, we're going to negate it. The mere fact that I am right now, sorry. There you go. So the fact that I'm going positive infinity means that my expression is positive. So it's this. So I could get rid of the absolute value sign, and we'll just have x instead. Now, when you have that, per usual, we're going to multiply by 1 over x like this, right? Which will yield us, x goes to infinity. If x goes to infinity, positive infinity, you don't have to write positive infinity. It's 7 over x. That is 1 plus, I don't know, 2 over x. And we know that that goes to 0 and that goes to 0. Yeah, don't do that in front of a math professors. They're going to yell at you for that. But I think AP graders won't yell at you for that. This will be sufficiently good. But understand that, yeah. Anyways, I'll just leave it at that. So that's going to be like what? 5 minus 0 over 1 plus 0, which is just 5. Okay. How about this? I'm going to kind of cheat a little bit. Okay. I'm going to copy this over here. I'm going to paste it. If you don't like it, why don't you get yourself a writing app yourself? All right. I actually bought Notability, and for about a year and a half or so, I didn't really use it because I didn't want to deal with the learning curve. But once I got over it, though, it wasn't that bad. Now, here's the key. We have an absolute value of x, but it's going to negative infinity, which means that x is negative. What happens when x is negative? I have to negate it as I'm taking it away. So that becomes a negative. That's it. And then when I do this, copy paste, I'm going to put a negative sign in the front. That becomes negative, doesn't it? So that is 5 minus 0 minus 1 plus 0 is minus 5. So we got horizontal asymptotes are y equal to 5 and y is equal to negative 5. Now it was asking for horizontal asymptote, so that's we have to answer that question. All right. Okay. All right, guys. It says find. Sorry about that again. Here comes the powerful magenta. I'm going to say find all asymptotes. Wait a minute. It said all asymptotes, not just horizontal. So what other asymptotes are there? Well, we have what? Also vertical asymptotes, right? Right. So how do we find that? Well, to find the vertical asymptotes, we set the denominator equal to 0, right? And that is, I believe, if I'm not mistaken, x plus 1 times x minus 4. Hence, x is negative 1 and x is 4. Those are the vertical asymptotes, right? What's the horizontal asymptote? Well, we're going to find the limit. Okay, we're going to find the horizontal asymptote is the limit of x goes to infinity in this case. We have x squared plus 2 over x squared minus 3x minus 4. In this case, I won't even bother putting the negative because if I did, it'll be positive here anyways. When these get really big, these become what? Kind of meaningless, right? So I actually didn't want all this to be magenta. Too much red, too much of a good thing. So let's go blue on this one. All right. So this is 1 over x squared times 1 over x squared, right? And that will yield us 1 over 2 over x squared, 1 minus 3 over x minus 4 over x squared. Now, imagine for a second, guys, if it was negative infinity, that'll be 0, that'll be 0, that'll be 0. It literally made no difference whatsoever, right? Just keep that in mind, okay? So that is equal to 1 plus 0 divided by 1 minus 0 is 1. Therefore, right, the horizontal asymptote is y equal to 1. So we're going to say, therefore, vertical asymptote is x is negative 1, x is 4. Horizontal asymptote is y is equal to 1. All right, guys, try to put it on the side so that we could find it easily, easier. For the next kind, we're pretty much done at this point. What do I do? So remember, we can't have infinity minus infinity because infinity is not a number. So this is said numbers getting big. This it says numbers getting really big. You could think of this as infinity plus a negative infinity, right? However, if this is approaching negative infinity much faster than this is negative infinity. If this is approaching infinity faster than this is approaching negative infinity, this is going to be positive infinity. If they're exactly the same, maybe it's zero. They'll cancel each other out. But we don't know that, do we? So we got to be very, very careful. So the idea here is this. When you get lost, what do? When you're driving around? You get to the point that's familiar to you, right? So what you want to do, right, literally like 9 out of 10 times, right, is put it in infinity over infinity case. Put it in the form where you know what to do with, right? Or infinity times infinity, because infinity times infinity is infinity. Isn't that right? That's right. All right, guys, here we go. So in this particular case, what I can do is x goes to negative infinity. That is x squared times x minus 1. So by limit law, you could separate them like this. By the way, that's negative infinity. You know what? I should write a little neater. You deserve that. Oops. You deserve neater handwriting. Now, look at this. Infinity squared, negative infinity squared is positive infinity. And if you look at this over here, negative infinity minus 1 is negative infinity. So positive infinity times negative infinity. So number that's getting really, really, really big times numbers that is getting negative big, you'll end up with negative infinity. Yeah, that's it. Now, I suppose you could do the same thing over here, guys. You could factor out the x squares. Highly unnecessary because this is infinity plus infinity, right? So when you split this up without factoring, please don't factor. Oh, by the way, one of the methods that we had over here was what? Was factor, right? But what if you just split them up like this? Right? And another correction. Here comes powerful magenta. I meant to put positive infinity here. My bad. All right. And then that becomes x squared. But that's infinity plus infinity, right? When you add two infinities, what do you get? Becomes infinite. Right. So in case when the direction of the infinity is exactly the same, add the two. Infinity plus infinity is infinity. Negative infinity plus negative infinity is negative infinity. All right, so that's not an issue. It's only when you go in the opposite direction, like this one, you gotta do something funky. How about this one over here, guys? Interesting. This one, another typo. This is what happens when you just copy paste. This is supposed to be positive infinity. And if you look at this, this is a square root of the x squared. It's essentially x here, right? That goes to infinity. So this is positive infinity minus the infinity. Oh my gosh. This is the same thing as this, isn't it? What to do? All right, guys. Well, some of you guys maybe said, you know the answer already, right? Anytime we had a square root of anything with something on the outside like this, what do we always do? That's right. We multiply by the conjugate. Isn't that right? So if I multiply this by the conjugate, x squared minus 5x plus x over square root of x squared minus 5x plus x, let's see what happens, guys. X goes to positive infinity. Well, this times this gives you, in case you forgot, if you multiply by the conjugate, you square the first times subtract the square of the second, isn't it? So when you square these two, you get rid of the square root. So you end up with x squared minus 5x. And then you multiply that together, you get negative x squared. We're done. And the denominator is just this. Oh, these two cancel. Now what can we do? What we notice is that square root of the x squared, that's essentially x, plus x is essentially something x, and that's x. I see. So this is one of those things that are what? Yeah. It is, they have the same degree, right? So we do what we always do. We multiply by the leading term value, which is like x in this case. So I'm going to multiply by 1 over x, like this, 1 over x. Unfortunately for me, this one has a square root, so I'm going to have to express this as a square root of x squared. However, lucky for me, that's positive x squared, positive infinity. So if I put a positive value here, and if I put any value that's positive, so denominator is positive and positive, so this expression is exactly the same. I don't know where I put it there. Oopsie. Okay, do you remember this over here, guys? Right? But the page before that, what I said was square root of x squared is equal to this. Square root of x squared is absolute value of x, which is defined this way, right? So any time that you have that, that's all we're going to be using. Okay. Anyways, let's multiply that out. And that gives you negative 5. And the square root of 1 minus 5 over x plus 1. And then you apply the rule, limit law, whole bunch of limit laws, right? But we know that the limit pops into this part, which will give you 5 times 0 plus 1. So that becomes negative 5, and that is a square root of 1 plus 1, which is 2. Alright guys, that was quite a bit of work, wasn't it? Okay, so that's it. I'll see you in your class. This is kind of long, so I hope you watched it like 1.5 times the speed. Alright, have a good night guys.